Hey guys, welcome back to the channel. Today we'll be diving into working with variables, data types as well as managing user inputs while working in Bash or Bash scripting. Bash scripting in Linux basically allows us to define and manipulate variables as well as we are able to handle different types of data depending on the data type. With user input we can manage inputs which are being present or prompted from the user. You might already be familiar with these things, but we will dive into them anyway. Bash, unlike other programming languages, does not define specific variables in a form of a data type. By default, obviously you can change it, but by default the situation is that the variables always remain as strings. Yeah, and obviously there are other things that can be also be done with it, but we will dive into this later. So let's begin with understanding variables in Bash. A variable in Bash is basically a placeholder for a value which can be used to store and retrieve data dynamically. Bash variables do not require a data type by default because they are strings, but obviously you can use them for numerical operations as well. Yeah, so by default, let's just try to set up the situation here. I'm gonna write this into my variable.sh script. I'm gonna import the shebang. Let's just write bin/bash. So yeah, the declaration of variable in Bash basically uses a syntactical structure somewhat like this, whereby which you will give the variable name followed by a assignment operator and the value. Always remember, in Bash you will never set up spaces at the point of assignment, otherwise this will not be recognized as an assignment or as an authentic assignment, because this is the syntactical nature of Bash. So yeah, you always end up with semicolon, and yeah, by default there is no specific data type which has been assigned, therefore by default it is string. And yeah, this variable basically will have the value as value. So yeah, that is the basic syntactical nature. So let us just say we basically create a name and we set up some value like John, some John Doe, and an age like 25. Always remember, whenever you assign, you should always have no spaces at the point of assignment. Bash otherwise will not interpret the command properly. So yeah, let us now try to access these variable values with the help of an echo command. Let's just display this information back to the user. So let's try something like echo. Let's say hello, something like my name is, and when you want to display the data, the variable name is always preceded by a dollar symbol or a dollar sign, which would basically be the placeholder for the value which would be later on depicted at the time of execution of the echo command. So something like this. And yeah, so let's just say quit as do chmod a plus x variable.sh. let's just do. So here you can see that we have assigned the value back into our echo statement, so we are able to retrieve those values correctly. Similarly, we can also utilize curly braces in a way to prevent ambiguity whenever we are using variables within strings. So let us try that as well. So we go back to our statement as before. So in let's just try to write something else. We can comment out these this section. So let us create a new variable. Let's say fruit, let's call it apple, and let's say echo I like, let's say dollar, followed by the curly braces. So here we are basically reducing uh, let's say the probability of this being incorrectly um, understood as a text. So here you can see the difference. Let me just showcase this further with another similar structure. Let's say if I write I like dollar fruit, but the issue here you will see here the second statement, the second echo statement is incorrect, because it will show that dollar fruits is an undefined variable, while in the first case, because of the curly braces, the unambiguity is removed, because only the value fruit will be the actually defined as the placeholder value which contains the term apple, while here the s is segregated or separated very clearly, and therefore this instruction would be understood as a term which will be attached next to apple, so it would basically come out as plural apples. So let's just try to execute this statement and let us try to do the same. So here you can see that our first echo statement, the curly braces allowed us to correctly segregate or make a distinction for our variable value, while the second case it was not successful because the s basically got clubbed with the variable fruit, and therefore it ended up as being fruits, therefore it was an undefined variable. So yeah, so this is a very interesting case, and therefore I would highly recommend, whenever you are using variables within strings, to always use curly braces. Another different form of using variables in bash is that variables can have a scope of accessibility, so it can be global or local, which would determine the scope and their accessibility. Let's say a global variable is a variable whose value would be available throughout the script, and any process or sub process which are within the script will be able to access it. So in order to set it up, let's try to perform this in a script. Before I do so, I would also like to mention local variables are basically variables which would exist within a function wherever they are declared. This would not be accessible outside the function or within child processes. So yeah, there is a key difference between them. So to do so, we will create another script called, let's say, scope.sh, and hit enter. Go into insert mode. Let's try to write bin/bash. We are importing our interpreter, and let's just say let's just give a comment, demo global variable. So yeah, let's just say, for whenever you are defining a global variable, you can also use a keyword called export. So this would make your variable accessible. It will basically specifically specify that this specific variable, let's say myvar, and let's just set it up as this variable is global. So this value or string value will be globally available. Let's just write something like this, and yeah, so this would be available for all your processes, child processes of the current shell. One another way to do this would be to, okay, I will show you in some others. Let's just exit out of this. Let's just write and quit. Let's just try to do that over here. Yeah, so you can let's just say yes, let's just set it up as something different. Set it up as I am global. So enter, and when you write bash -c, and let's just print out our echo $value myvar, when I hit enter, you can see that this value is now globally available. So for more clear distinction, I can show you within our previous script which we just left. So since I have this value which I have defined it over here, I will now write another function. So let's say my function, and let me just set my function. I will write local, and the same structure, let's say my var, I will give the same name, and I will say, let's say I am in local scope. Let's just say something like this. Just, yeah, and let us just echo this specific value. Let's just say dollar my var. So let's now go, and here we will invoke our function. So we'll write function. So here we will get an output as I am local, while when we print the echo statement for the same variable which exists outside the scope of this function, we will get let's just do this, and yeah, here we will get the output, this variable is global. So yeah, let's just try to run this. I think I have to do this. Yeah, I forgot. chmod scope.sh. Let's just try to execute this. So yeah, you can see that though the value or the variable that we defined are the same names which were given, because of their scope the values remain different. So the key difference here is that since sorry, let me just scope.sh. So the key difference here is that local variables will only exist within the function within which they are declared. So this particular variable, which has the same name as this as before, because of it being a local variable, the value would remain something like this, which is obviously different from the global value which we had previously declared outside the variable, and that's the key difference. So yeah, the value of global variable will basically persist throughout the script and the child process. So yeah, I hope you got that, and now we will move on to handling user input in bash. So let's just clear our workspace, and let us say let's say user input .sh. Here we will go into insert mode, go bin/bash, import our bash interpreter, and we will write echo. And as you might already know, you will write, let's say we just ask the user for his or her name, and then we will return the same value back into the terminal. So we will write let's say something a little bit friendly message, hi, what's your name? Something like this. Here we will write read followed by the definite variable which will be listening onto the prompt that the user would enter, followed by the value which we will display back, which is stored within user underscore name. So we will write user underscore name. So yeah, we will now exit. Sorry, we will exit. We will write chmod user input .sh, and we will write user input .sh. Here we will write some name like this, and when I hit enter, you can see that the read username basically stored the user value that was provided and basically was shown out into the terminal through the echo. You can also do some different methodologies as well. Okay, let's just say XYZ. So yeah, let us just go back to our same structure as before. Here we will go into insert mode, we will comment out our statements. Yeah, so let us try to now prompt on the same line, unlike before where the prompt would basically appear on the next line. So here we can basically structure the same command as before, where the read would be listening to a variable. So here we will write read hyphen p followed by let's say hi, what's your name, something like this, and we can basically give out user underscore name, which we will promptly output. Your name is $user underscore name. So yeah, so the difference here is that we are basically performing the process of entering the value directly on the same line instead of the second line. So yeah, that's how you basically do this. You basically use hyphen p and basically write the same input on the same line, and that basic data gets accepted onto user underscore name and is outputted on the second line. You can also use a different methodology in order to work with users who are entering credentials which might be private. You can basically hide their input. So let's say if a user is inserting passwords, you can basically use a different format as well. Let's just go back to our same structure as before. We will comment out our statements, and let's say here we will prompt the user to enter a password. So for that you basically use read as before hyphen sp, which is for basically hyphen s basically stands for secure, and here we will write please enter your password, something like this. Password, something like this, and we basically take the password variable and let's say something like this, echo e type an n password received. Yeah, so let's just try to do that. So the idea here is that once you execute this command, here your values will not be visible onto the terminal as you type. So let's say if you type, let's say something like this, you wouldn't, I just typed my information in, but obviously as a viewer you can't see it, because I have hyphen s, which prevents this information to be visible. And once I hit enter, it would basically show that that specific data was successfully received, and we have executed the second statement, which is echo command. So that's how the process of hiding inputs, especially whenever it comes to sensitive data, basically takes place. So you might be wondering, if I am gonna work with inputting or taking user input, I am not gonna be interested in just taking one specific input at a time. So for that you can also move on to reading multiple values in one command itself. So let's say if you want to take the first and last name in the same command, in the same statement, you can do so that, as well. So let's say we will write another let's something like let's say multi input or something, just some name like that, yeah, whatever. So we will write something like this. Go into insert mode, we basically bring out our interpreter into the terminal, and let's say go into insert mode. Yeah, so we will write echo please enter your, let's say, first and last name, something like this. Let's just something like this, and yeah, let's just read this information. For that you would basically write something like this: first name, last name. Then you can basically display this information, hello, something like this, followed by the first name. Okay, always remember, whenever you are using such variables, always try to follow up with the standards which are set up. You should never use numbers along with your variables, otherwise it will show up as unusual. So let's go with something like this. So here we are basically taking the user's first name and last name together on the same input. We can also modify this unlike this. We can, let's say we try to take up some extra information, um, like let's just say let's try to read -p, please enter your age and let's say address, or let's say street where you live, something simple. Something like this. And yeah, obviously you have to mention your variables at the end, otherwise it won't work. So let's just say age followed by, let's say, street, and here we will just echo the, let's just give out simple structure like this, $age, and let's say street, some simple structure like this. So yeah, this is just to show how different ways of taking or reading values can occur. So let's just give out chmod multiple input.sh and go out and write something like this. So yeah, here we will write, let's say this is John, okay, yeah, here you give it like 23 and let's say 5th Avenue or something. So yeah, this works well. Yeah, I made a small error when it comes to, as you can see, there was some issue while it did not depict the last term. You will always separate or segregate your data within curly braces because it's a good practice. So yeah, let's just try that again. So let's say we will write, let's just write John Doe, and let's say 24 Avenue. So yeah, this is pretty much the way we can do inserting values. But another way to take input from user would be smart to set up a pre-existing value by default, which would act as a replacement whenever the user fails to provide a value. So what happens is that default value will be showcased in your output. So to do that, we will set up, let's say, vi default. Let's just say something like this. Go into insert mode. Let's say we basically ask the user as usual before as a statement. Let's say please enter, let's say something like student roll number or something. To your student roll number. So here, let's say we would set up a default value. We are just specifying this information as 000 as a 4-digit numerical value. If this digit is not provided, we will basically go back to this specific number. So let's just set up that roll number variable and let's just read it from the user. And here we will set up the default value as, let's say, something like this. For that, you basically use these specific symbol, the double colon and a hyphen, which would point to the default value. let's say some default value as I have mentioned, so like 000, and here we would basically echo out the user input. So we mention your, let's say, student roll number is dollar roll number, something like this. And yeah, you basically quit out of this. Let's just try to add x default set. We'll try to execute. So here we basically give out a random, let's say 1 2 3 4. Once you hit enter, you can see that our value which we provided was shown. But let's say in a specific scenario we fail to provide or do not have that detail, and when we hit enter, you can see that that value was not empty but got replaced by the default value that we just provided. So yeah, this is pretty neat whenever you need to handle or foolproof your programming structure whenever it comes to taking user inputs, or if you want to give a provision of a default value for it being assigned for such scenarios. So yeah, similar to this, we can also handle numbers. As of now, we just dealt with strings. So let's just say we want to perform an arithmetic operation. Let's say we will just add two numbers together. So let's just write, let's say vi add .sh, and when we hit enter, we go back. Let's just say bin/bash. Yeah, so we will set up our numbers. Let's say num1 10, num2 something like 15. Yeah, and here all the numerical operation basically takes place within the double parenthesis where you want to specify it as a value. Num1, let's say num2. Hit enter, you basically mention something like this. Sum, let's say $sum. So yeah, you can also take it as a user input as well, but as of now we will just try to keep it simple. So let's just do something like this. X search. Let's just do this. Yeah. So yeah, you can see that we just perform the operation of basically combining two values together. You can also do the same operation with the help of another structure which exists within Linux. So we can basically do the same operation as before, but you can basically specify the expr which basically allows you to specify this as an operation which is being, or an expression which is being conducted. So let us set that up. So we will write sum equal to $. Let's just write expr. Let's just write num1 plus $num2, some structure like this. This will basically do the same thing that we just did before, but this is a little bit more easier to showcase whenever you are trying to depict expressions. So here you can basically write something like let's say if you write this, let's just say if you want to show it as an equation, you can basically go up and write this as expression 1, and we can basically show the sum here. Let's just say sum of, let's just say $ex1 is equal to some structure like this. So I can quit. So yeah, this works too. Similarly, you can also deal with floating points, but by default Bash does not support floating points natively, so you basically need to specify. Let's just rename our script into, let's say, calc.sh, and let's just try. Yeah, we have successfully renamed our file. Go into calc.sh, go into insert mode. Here, instead of performing this kind of operation, let's just say some value like this. Whenever you do this specific process, you always need to specify um, some value which basically allows you to handle floating point arithmetic operation to be conducted. So you can basically write the same structure as before, but here we will basically give out a pipe command with BC, which basically is used to highlight or indicate that this operation that we are trying to perform is an arithmetic operation. Here in this case we have combined the echo command into the mathematical operation that we are trying to do here. So we can basically do something like this. Yeah, and this will work out fine. And yeah, let's just try to print out that output as well in a brief way. So here this we need not specify this statement, so we can just specify something like this. Yeah, and let's just try to execute this. Note that before you execute this structure, you might need to install BC, which is a command for handling floating point arithmetic operations. If this has not been installed, you will basically get this specific error that we just encountered. I had to do some digging, but this is the situation. Our command structure would remain the same, and once we hit enter, you can see that we have successfully performed the arithmetic operation of combining or finding the arithmetic sum of two floating point numbers. So yeah, you have to make sure that this version of command BC is basically installed, otherwise you will not be able to work with this. Yeah, and similar to this in bash, just like we just demonstrated all these different variables, there are also environment variables, which are global variables which exist whenever all processes are happening or are in session. So to find the values for these environments, if you try print env and hit enter, you can see a bunch of pre-existing let's say system variables which have been defined way long before as default. So each of these values have a specific default value which has been set up, like if you type echo $home and hit enter, you will get the home directory path. Similarly, if you type $user and hit enter, you will get the current logged in user. You can also create your own environment variable. Let's just try to do that. If you set up myvar as before and hit enter, and let's just type echo $myvar, you basically have performed that kind of an operation which we just showcased a few in the few early hours or early minutes of our session. So yeah, this is how you can do it. You can also remove these from your environment by basically typing unset followed by myvar, and when you hit enter and when you try to execute this, you will not get an output because we have effectively deleted that from our environment. So yeah, I hope you learned something today. So let's just try to summarize. Whenever you declare a variable, you will basically write variable name followed by the value with the assignment operator. Always keep no spaces between these values. Accessing these variables basically requires you to specify a dollar symbol before the name of the variable, Good practices basically would allow you to set up the variable name between curly braces in order to avoid an ambiguity. You can set up your global variable with the help of export command, so something like this. You can basically remove it with the help of unset, which would remove that variable from your environment. You can basically set up local variable with the help of local value, so something like this, local variable, so it would have a value as such. You can basically take user input with the help of read, which would take the user input and store it into a variable. Arithmetic operations can be done by the process of specifying your uh, operation within double parenthesis, whereby which the double parenthesis would enclose the actual operands and operators. Floating point calculations always require you to specify um, BC at the end, because it's a command for performing floating point arithmetic operations, especially within context of decimal calculation. And you can get hold of all your environment values with the help of print E and V. So yeah, this basically covers all this information related to variables, scope related to variables, and the user handling of any input. And yeah, I hope you understood a lot about these concepts, and I will meet you in the next one. Bye.